Okay, let's talk about the graph of secant of x. Well, first off, recall secant of x is just 1 over cosine x. And we should be really good at graphing cosine of x by now. If we were to graph, say, a couple of periods of cosine, we know what the graph of cosine looks like. You should be good at this by now. This is 2 pi, one complete period from here to here, making this halfway spot pi, and this first x-intercept, pi over 2, and here's 3 pi over 2. And maybe we'll go backwards a little bit here as well. Maybe we'll come back a full period. So this would be negative 2 pi, negative pi, negative pi over 2, and negative 3 pi over 2. So that's cosine. Secant is 1 over cosine. Remember, we can't divide by 0. So any place cosine is 0, secant's going to be undefined. So if cosine of x is equal to 0, secant of x is undefined. Meaning we'll have a vertical asymptote there. Well, where does that happen? Let's look at all these places. Cosine of x equals 0 at, well, how would we describe all these spots right here? 3 pi over 2, pi over 2, negative pi over 2, negative 3 pi over 2. This next one, 5 pi over 2, 7 pi over 2, 9 pi over 2. That's not all the pi over 2's. You might say, oh, every time we have a pi over 2. Technically, this guy right here is 2 pi over 2. And 2 pi, he's 4 pi over 2. So it wouldn't be all the pi over 2's. It would be the odd pi over 2's. At n pi over 2, where n is odd. So if n is an odd number, 17 pi over 2. That's one of the places cosine is 0, so secant of x is undefined there. Because you can't divide by 0. So then what's the domain of a secant? The domain would be all real numbers except those bad places. Where n is odd. And then we'll talk about the range once we get the graph. Okay, so we got cosine. Let's quickly sketch out that cosine again. So I'm not graphing secant yet. I'm just sketching out cosine again real quick. So this was 2 pi, pi, pi over 2, 3 pi over 2. All these places here where cosine crosses the axis, secant is going to have a vertical asymptote. So to graph a secant function, we kind of take a cosine function and we turn it inside out. We flip it over. So let's put on top of this, so this black graph here, this is y equals cosine x. Let's use blue and put a secant graph on top of it. So at all these places right here, we're going to have asymptotes. Every place cosine crosses the x-axis, secant has a vertical asymptote. And again, that's all the odd pi over 2's. Now, how high is this? This is at 1. Secant is 1 over cosine. Let's kind of think about this for a minute. What will 1 over 1 be? What is secant of 0? If I plug in a 0, cosine of 0 is 1. 1 over 1 is 1. So our graph we're actually trying to graph has a point right there. What about, I don't know, maybe a spot in here? Like maybe 60 degrees, pi over 3. Cosine of 60 degrees, pi over 3 radians, is a half. So that's about here. What's 1 over a half? That would be 2. See, as cosine is going down, 1 over that would be going up. Secant will be going like this. And same thing back here. What about down here? Same behavior in this region, only instead of being positive, all these are going to be negatives. And same thing here. So we kind of see all these little humps and valleys here. See this little hump right here? We take that and we flip it over. Instead of facing concave down like this, we face it concave up. All these little humps and valleys get turned inside out. So this blue graph is the graph of secant. So we could, like if we just wanted to graph secant, we could go through and erase that cosine graph. That's the graph of secant right there. We first graph the cosine, we put in our asymptotes, and then we take all those humps and valleys and just flip them around. So if we were only graphing secant, if we were typing this in a calculator, this is the picture we would see. But remember, in this class, I always want to see your work. How did I generate this graph? Where did it come from? I had that cosine graph to help me. So that cosine, it's not really part of my answer. It's kind of like part of showing my work. So that's the way we're going to graph secant. We're going to graph the cosine graph first, and then take that cosine and flip it inside out. So a lot of times, just to illustrate that, I'll make this cosine graph dotted or dashed or something. And you'll see that as we do some examples. Okay, let's do an actual example. Oh, here, let's write the domain and range first. So my domain, like we said a minute ago, is all real numbers, except n pi over 2, where n is odd. What about my range? We're going up here to 1. We're going down to negative 1. Range is always smallest to largest, going up and down. What's the smallest? How low does this go? This goes down to negative infinity. Up to, how high do I go? Which y values am I using? I'm using all these y values up to negative 1. Then I got this break. I've got no blue graph in between here and here. Then I start using all these y values again. So nothing in between here and here. Then I go from 1 to infinity. Cosine is between here and here, negative 1 to 1. That's cosine's range. Secant's range is everything else, everything except this stuff in here. Okay, so let's do this. Let's sketch this guy here. Y equals 3 secant of 2x minus pi over 2. So we know to get secant, we got to do cosine. So we forget about secant for a second. First, we sketch the cosine, the same graph, but cosine instead. We'll get the secant in a minute. We should be really good at graphing cosine graphs right now. We've been doing those for over a week. So we find the amplitude. Amplitude's absolute value of A. A here is 3, so our amplitude is 3. We find our period. Period is 2 pi over B. B here is 2, so we get 2 pi over 2. Maybe we want to write that as pi. Maybe we want some other denominator. We don't know yet. Our phase shift, opposite of C over B. So I want the opposite of negative pi over 2, positive pi over 2, over B. 2. That's pi over 4. And then we want our vertical shift. We don't have a plus anything out here. K equals 0. So we have no vertical shift. K equals 0. We do our start and end. So all of this should be reviewed. We've done a bunch of these. Inside equals 0 and inside equals 2 pi. We're just graphing a cosine for now. So this is 2x equals pi over 2, x equals pi over 4. And that should always be the same as the phase shift. This is really just a check. And then end here. We're going to get 2x equals 2 pi plus pi over 2. I need a common denominator to add those together. That common denominator would make this 2 pi 4 pi over 2 plus 1 more pi over 2. That would be 5 pi over 2. So divide by 2, and we get 5 pi over 4. And then we should always check end minus start should equal the period. And we can just do that in our head. 5 pi over 4 minus 1 pi over 4 would be 4 pi over 4, which is pi. So here, let's write this guy in terms of 4s. Let's use the same denominator for everybody. Everybody's got pi over 4. Okay, then our x scale is the period over 4. So our period, pi, over 4. Look, everybody's in 4s. That makes us happy. Okay, now we draw a nice pretty cosine graph. Now again, I'm going to draw this one dashed because this is really like an auxiliary graph. This is like a part of the work. This is not going to be my final answer. It's not necessary, but I think it's a little cleaner if we draw this dashed. We have no vertical shift, so the x-axis comes right through the middle. Okay, we're doing cosine. Cosine starts and ends at crests. So here's a start and an end. I just picked some random crests. I know what numbers to put there. Here's my start. Here's my end. And now I'll just start counting by my scale. There's 1 pi over 4, 2 over 4, 3 over 4, 4 over 4. Hey, 5 over 4. Yay. Going backwards. Remember, we're counting every crest, trough, and intercept. Going backwards. I'm at 1 pi over 4. If I subtract 1, I get 0. Oh, that's something special. That's the y-axis. Let's do a few more. There's -1, -2, -3, and -4. Okay, that's cosine. Oh, let's put on our amplitude. I think that was 3. So this down here will be -3. Okay, that's cosine. That's our auxiliary graph. Now we're going to flip this guy inside out. So I'm going to do this in a different color. I'll do it in blue again. At every one of the intercepts, at all of these places where across the x-axis, I draw in vertical asymptotes. Now I just take all these little hills and valleys and I flip them inside out. Like this little hill right here. See this guy right there? I'm just going to take it and flip it up. Everything that's above gets flipped up. So my graph of actual secant, and those touch. That's important that a lot of times I'll have people do like this where they don't touch. Now that comes all the way down. And these valleys, all these ones below the x-axis, they get flipped down. Everybody gets flipped outwards. Above gets flipped up, and I kind of missed there. Let me make sure you come down and just kiss it. These ones below get flipped down, and so forth. Yeah, that's all right. Just make it a little bigger there. So this blue graph is the graph of what we were actually trying to graph. 3 secant of 2x minus pi over 2. Now, on the test, on written assignments, if you don't make this cosine graph a dashed or dotted, it's no big deal. Don't worry about it. You do need to put in these asymptotes, and like the blue graph that you're seeing here is our final answer, though. That's a good place to stop.